Good day, good afternoon, wherever you are. I appreciate everyone joining in for today's session on improving your finance AI strategy with humans in the loop. We've got an exciting session on today, and I'm pleased to have Pieter now, who is our CTO with Cloud Factory. And before turning it over to Pieter, just a very quick introduction. Cloud Factory is a global leader in combining people and technology to deliver AI solutions. We are specializing in data labeling, annotation, and automation initiatives. We've been around for over 12 years with over 7,000 expertly trained staff and have helped over 700 companies globally to date. So with that, I will turn it over to Pieter.
Yes, thanks, Errol, and welcome everyone. I am Pieter Nel. You're going to immediately pick up an accent, so I'll tell you that I'm originally from South Africa. I did my master's degree in AI a good 20 plus years ago down in Cape Town. And since there wasn't much going on in AI at the time, I spent a full career in the world of mobile social networking on 3 different continents. And then finally got back into it a couple of years ago. I did a very strange thing for an engineer. I joined McKinsey here in New York. But that was a really insightful 2.5 years where I spent my time as the local AI expert, and I got to see the entirety of industry and the challenges folks are facing in adopting and using this technology. And from there, I moved on to a company that did document analysis using human-in-the-loop AI. Also in New York, spent 2 years there. It's a fintech company, so very applicable, I think, to the audience that we have today. And I was lucky enough to join Cloud Factory last year as CTO. So that's me in a nutshell. And I'm going to move on and just start looking at some stats here, and then we can go into some of the practicalities in terms of what we can do to adopt AI in the fintech world. So one of the first data points that we have here is that, and this is from Gartner from a while back, that only 16% of decision makers feel that financial data can easily be leveraged for decision making. And that's really an indictment on some of the difficulties that folks are facing in just using what is there and what is available. So if you feel like you're not quite up to speed either, just realize that you're not alone. This is still a fairly common industry challenge. And if we go to one of the next ones, this is from a recent McKinsey report from my previous colleagues. And some of the highlights here is that what they've seen is that there's been a very fast adoption of AI in the last 5 years, but that this is now again plateauing at like 50-60% adoption in industry. And again, it's like we're hitting another ceiling in terms of adoption, and we'll go into some of the challenges and why that exists. Just some other extra data points here is, of course, in the financial industry, robotic, this is across the board, but this is also applicable to finance specifically, is that robotic process automation remains the top tool that is being used. And of course, there is so much manual processes in this industry still that it's not hard to imagine the impact that is coming from RPA and providers like UiPath, etc. But the very next one down, which may surprise you, is computer vision. And it's not necessarily completely obvious that computer vision should be this applicable. Not only, again, this is across industry, but a similar thing exists in finance. And I'll explain in a bit as to why that is. And then, of course, there's the NLP and virtual agents and so forth that you would be familiar with. Next up, and it is basically you have kind of 2 opportunities, and it's related to the types of data that exists. Especially in finance, there is a lot of structured data. So structured data is just your databases, your large spreadsheets, things that have numbers attached to it. And we've used that in this environment for decades, of course. Things like deep learning has allowed us, though, to be way more effective and efficient. For example, if you look at fraud detection in the credit card industry, those algorithms have now all shifted to be deep learning based, and it is providing like step changes in the level of effectiveness. And the other one is like this classic AI, and AI is also a little bit of a placeholder term. Every time we invent something new, that becomes AI. So AI is has a continuously shifting definition, but right now it is all the stuff that you see when you read the tech press, computer vision and being able to automatically detect things in your environment using cameras. And here we have opportunity across the board. Of course, this is what drives self-driving cars and all these other things, but there's also opportunity here in the world of finance and document processing. And we'll get to that in a second, as I mentioned. So as a further overview, if you look at financial AI use cases, the one that I've been mentioning is, of course, document processing and entry. And this is traditionally quite a heavy lift. First, it was just done manually with like large groups of people that had to do the document entry. It's progressed somewhat with optical character recognition, and it's now again rapidly progressing because of the applicability of computer vision techniques that we've really trialed in other areas like self-driving cars. Fraud detection is a common one. Like I said, that's always been a problem. That's always been something that is addressed through machine learning, but the capabilities that we've gained over the last couple of years in terms of neural networks and deep learning and these things have allowed us to be much more effective with fraud detection. Risk assessment, again, something we've always done, using lots of different data inputs and forming, providing risk scores and understanding risk. But again, it's also substantially getting better just because there are better algorithms available to us. And the last one, there's things like that uses now classic computer vision. And this is things like you've seen these claims processing automation where you take a photo of your car and the algorithm using computer vision is actually determining the extent of the damage and the impact of the damage. So this is bringing like the normal fancy Google style computer vision solutions also into the world of finance and insurance, etc. So next up, I wanted to get to some of the crux of what I wanted to discuss today, and which may be not entirely evident to folks that isn't deeply embedded in this industry. And this is just how computer vision is now applicable to this world of finance and document analysis and document processing. So the image you see on the left is, the classic one that you would see in the media that is used all the time to kind of showcase computer vision. And this is where a deep learning algorithm has been trained to spot different objects in its environment. So you see it draws the box around the truck and it calls it truck, and it draws the boxes around the cars and it calls it cars. And it draws the little green box there at the top left around the road sign and it calls it road sign. And this is done firstly by training thousands, if not hundreds of thousands of images with humans. The humans has to draw the boxes and teach the machine ultimately what these objects are. But if you do enough of these and you label enough of these images, the algorithm will learn and it will automatically be able to detect those things in the environment. And it doesn't matter where they appear in this image, it'll detect it regardless, because it starts learning like a human does. It starts learning different shapes and it starts to identify them based on the context of where you find them. So there's layers of intelligence built here that is derived from just looking at hundreds of thousands of examples. Now, we can and are using similar techniques these days in document processing. So in the old days, what you see here on the right is just a classic pay stub. In the old days, you would take that thing and send it through basic optical character recognition, and all that'll spit out for you is just a bunch of letters and figures. And it becomes really hard to actually take that and still make sense of it, because there's no intelligence at all in these OCR algorithms. It just takes whatever it sees on the page and dumps it in the text file. And it takes almost as much work to do it, to make sense of that for a human, as it would have been to just like data capture it from the beginning. So it's never been great, especially for documents like pay stubs that has a large element of variability, because they look different for every single company that issues a pay stub. And of course, when you're dealing with finance, things like pay stubs and W-2s and the bank statements are the key inputs to so many lending decisions and credit decisions and so forth. So this is like the staple in finance and consumer finance so often. So what has now happened is that using the same computer vision techniques that we used on the left for self-driving cars, we're now using this in document processing. And you'll see an example here where if you look at the top right, it's almost as though the algorithm took a highlighter and it's been trained to do exactly this. Like, that it'll look at the document and it'll find the pay period and highlight it, and it'll know that that is pay period irrespective of where it appears on the page, because it's been taught to do that. And now there's context. Now it's not just a bunch of numbers with a couple of backslashes in it. It's actually been tagged as a pay period and two different dates. Similarly with the date in blue there, it's been trained to highlight that, so to speak, and it knows that that is the date on which the pay stub is issued. And similarly then with, I gave two more examples here, but it'll do it on everything that it's trained on, and you can train it on every aspect of a regular pay stub, and that is the employee address on the left there in yellow, and then finally the net pay on the right-hand side in green. So now you have context, and now running this through a model, you actually extract the underlying data that is in a pay stub, and it's not just a bunch of numbers. It puts it in the right field, so to speak, in your application, so that it knows what a pay period and a net pay and a date is. And even more importantly, and we can go to the next example here that shows a receipt. It'll do the same thing even on literally a crumpled receipt like this that you took a cell phone picture of. So now there's smudges, there's discolorations, but the computer vision is able to read through that and not be disrupted by it, and still find the relevant fields as it has been trained to do. So, so much of consumer finance, for example, is these days, it comes from folks having to take photos of things from the mobile apps. And so this is a common problem, actually. It's a lot, especially when it comes to receipts. This is how they're processed. It's not like it's a beautiful, generated PDF that you can just send into someone. Most folks take photos of these things. So again, this is a substantial advance using computer vision technology to automate document processing, which really powers so much of finance. So if you go to the next one, then here, if you do get a very clean receipt like the one there on the left, that's a bonus. That's what we all want. But computer vision techniques allow you to make everything look like that, basically. But the other key part here is to then involve the humans in the loop, as we say it, because once you've extracted data from any kind of document, there is still an element of oversight and correction that is necessary, because none of these things are 100% perfect. I'm going to paraphrase Rodney Brooks, who is one of my thought leaders in the field of AI, and ex-MIT professor and founder of iRobot, and he says that the kind of secret that no one tells you these days is that if you're doing anything of consequence in AI, things that has safety aspects, so human life that is at risk, or there's a large cost to failure, like you get the numbers wrong and you lend someone money based on an automated process because you weren't accurate enough. In those kind of environments, safety and the large cost of inaccuracy, everyone still uses and will continue to use humans in the loop that does the final validation and cross-checking. And what we see here is an example of how that is done, where you've got the document on the left, but the data has been extracted on the right-hand side. And using humans, you do like a final check to make sure that you actually have this data captured 100% correctly. And even though this is a receipt validation, you can imagine that when you're doing this with folks applying for loans through bank statements and W-2s, you kind of want to make sure that you've got the numbers 100% and you're not missing a zero. So this is just to demonstrate, the human in the loop aspect of AI, and something that we at Cloud Factory do a lot of for all our clients. But that is pretty much an industry standard at this point, in that you cannot have the 100% accuracy on document extraction unless you use humans in that loop. So as a final one here, this shows the market opportunity also from a recent research report, that the AI opportunity in fintech is still predicted to grow at a compound annual growth rate of 16.5%. But from that 9.4 billion in 21 to 41 billion in 2030, which just shows you what lies ahead for us. And it's super exciting because there is still so much that one can do by just using a little bit of intelligence. And if you can overcome some of the blockers that we started this webinar at, that 30-odd billion is ours to capture. So at this point, Errol, I'm going to hand back to you to see what we're seeing in the industry polls.
Yeah, that's a great insight into a real practical example of where this technology can be applied to. So just as a bit of transition here, this is a question came out in a recent industry poll. Which industries are the most ready for AI transformation? So as you ponder that, I'm going to pop up the outcomes of this poll, and this was done by Riley back in 2021, not too long ago. Perhaps not surprisingly, is that the leading category there, 17%, is computers, electronic, and technology. So most of us would anticipate that yes, high tech is the first adopters of AI. But I think what is rather surprising here is that just right behind at 15% is the financial services sector, of which many of you are involved in. So it does bring home the sort of reality in terms of how rapid adoption is taking place for AI within this exciting sector that we're all part of. So with that sort of insight, turn it back over to you, Pieter.
Yeah, great. Thanks, Errol. And, quite, I would say, maybe again a counterintuitive number, but also a very exciting number that indicates just the opportunity available to us. So in the next section, I'm going to talk about, okay, so how do we accelerate our ML and AI projects, also specifically using humans in the loop, because clearly things are getting stuck a bit, and this is what I'm talking about here is one of the ways to address just accelerating the adoption and use of AI. So if you look at this slide, every single stage of the model development process is driven by data, and the ML process is no different from the standard software development process. Really, you start with a design and build phase, and then you deploy and operationalize, and then finally you refine and fine tune. You don't spend years making this thing perfect and then launch. I mean, we have to do that in aerospace, but in other industries, you get to market and then you optimize from there. But what is surprising and always been a challenge in the AI space is just to make use of all these new deep learning algorithms. The key thing that makes them work is that they require an enormous amount of data. And once you've given them that data, yes, they get really smart. But so when you start in the design and build phase, there's a huge amount of data required very often to train some of these models. And just my industry experience, if you're looking at a model that is going to automate one of these documents, I would say it's easily 50 to 100,000 examples of that thing that has to be labeled and annotated by humans in quite extreme detail. And very often that's quite a barrier. And then the second one is, the same thing when you deploy and operationalize. You still have to ensure that what you trained it on is actually what is happening in real life. Very often we've seen that there's exceptions that you just didn't account for. If you just think computer vision, if you trained all your models by teaching it on photos that was taken in the summer, it's not going to understand how to deal when there's a sudden snowstorm or icing incident in Texas, as has happened. So again, you also have to continue to add and fill in the gaps in the data. And then lastly, once the model are actually in production, you still have to update fairly frequently, just because what we call model drift happens. It's if you have an insurance application and it's been trained on looking at damage in different cars, like a year or two from now, those cars look different. It's the new model year, and suddenly the model don't really understand how to deal with these new models because they look different. So again, that happens kind of all the time. If you think in documents, the document layouts start looking different. The pay stub provider may have just decided to shift where the date sits. So you continually have to refresh also. So all of this means that there's actually quite a labor-intensive aspect of deploying and using machine learning in practice. If we go to the next one, you'll see that these data acquisition, data cleansing, and every data scientist will tell you this, that 80% of the time is spent on that. Finding data, making sure it's clean, getting rid of all the exceptions, getting rid of all the poorly labeled instances and errors in your data. That takes up 80% of project time, and again, is extremely human and labor intensive. And then once it's deployed, every time this thing makes an error, it's based on failures in data quality, data labeling, and that, garbage in, garbage out. That stuff leads to unreliable models. So, there's stats here that the failure rate for AI projects today is still kind of 8 out of 10 that fails. And it has to do with this. It has to do with just the amount of time and effort that is required upfront, and that very often folks just by necessity maybe just skip through. But going back to why we see kind of a plateau in AI adoption, it's because of this stuff, because this ends up really biting, and teams lose credibility when stuff gets rolled out and it's not performing perfectly, and it performs imperfectly because of problems in the data. So now what do? Well, this is where things still become somewhat labor and human intensive. And that is that in these critical phases like data cleansing, data annotation, the quality control of annotation, and then once things are in production, being able to handle the exceptions where the machine learning algorithm isn't perfectly confident in its output, these are all things where humans are involved. So, again, the fancy Silicon Valley companies may want you to think that everything is automated and everything runs by itself. But the reality is that everyone that deploys AI still is required to spend a substantial amount of human time on these aspects and for the reasons given, because this is the only way you actually assure that things are usable. So what we've come to call this in the industry is that for the first decade of AI, everyone was focused on the algorithm, and fine, because that's what led to the breakthroughs, is substantial research advances in like the 2012 time span, and that's a decade ago. And so for the first decade, most folks spent their time on improving algorithms. That now has pretty much been commoditized. It's like there's no further advance in algorithm, okay, unless you're dealing with things like Chat GPT and all these new things we're now hearing of. And that's really the first new innovation somewhat in the last decade. The rest has just been incremental improvements. So what the industry is now shifting to is what we call the data-centric approach. And this is where we realize that, okay, given that the model is kind of a solved problem, where do we spend our time on? Well, we spend our time on improving the quality of the data. Again, garbage in, garbage out. So if you put quality data into a model, you'll get quality results out the other side. And this is basically a fairly substantial shift, right, over the last year and a half or so in industry, where everyone is now starting to talk about data-centric machine learning. And it's great news for deploying machine learning, because it means that if you have a partner or you can work with people that can help you fine-tuning the data, your data asset is really the thing that makes you unique and that gives you the strategic moat in your business or your industry. The models are commoditized. I mean, everyone just downloads them and the papers are published online. So, but what the secret sauce is if you can train it with unique data to which you uniquely have access to. And there is still so much prospecting even that one can do in industry to find areas of unique data in your business that only you have access to. But that stuff is the gold, because that gives you the capability to build something that is unique to you. So the next one, it really describes this approach of how folks are changing from a data-centric to a changing to a more data-centric approach. And like with normal software, the iterations in machine learning also speeds up time to market. So we follow that same model here that you follow in normal software development, in that you rapidly iterate through collecting images, training models, and then fine-tuning, seeing how it performs, and deploying, and just running through the cycle all the time. And what a data-centric approach allows you to do is that you can kind of work on the model and the data in tandem, that you can start putting something in production fairly quickly and just then rapidly feedback. And if you see, okay, it's not really great at distinguishing things that are taken in low light, then you just go and find more low light examples, and you label those and you feed that into the model. And so by rapidly iterating and finding exceptions, you get to market faster. And we all know that the faster you can get to market, the better the chance that you capture a unique piece of the pie for yourself. So next up, it means that we don't really have to sacrifice quality for efficiency. That by involving humans, by being really thoughtful about rapidly labeling the right images or documents, and launching and seeing how it performs and running through those feedback loops, you're quickly able to ramp up your quality while keeping costs down, instead of what used to be the case in the past, is that you spend a year first just cleaning up data. So again, the human in the loop aspect and the iterative aspect of machine learning is allowing us just to get to market faster, which is good news for everyone. And I think this figure 8 also helps to illustrate why integrating humans in the loop offers an end-to-end iterative capability like what I've described. So the whole point here of this figure 8 is that it is a continuously running loop, like I described. And you start with, like, you design your strategy there at top left, you label your data, you train your model, you deploy, you do your model monitoring, you find the edge cases, like the things I just described, like, yeah, it's not great in low light. You find more examples of that, you label them, you train the model again, and you keep iterating like this. The thing with that is that you need the humans pretty much as your partners, because data labeling is done by humans. The exception monitoring and finding the edge cases is done by humans. So the model monitoring very often is done by humans overseeing the model. So this is why it's key to understand that humans aren't going away, and that humans in the loop technology allows you to get to market and iterate faster. So again, at this point, Errol, I'm gonna jump to you and to give us another insight industry.
Yeah. You know, it's a great thing. Appreciate that walking through and talking about the shift from towards a data-centric approach. So referring back to that same report, this was another question that was posed in that report. What are the key bottlenecks to AI adoption? So remember, previously we talked about that transition going around across all industries, finance being, the second most important industry to be adopting. The results of this are shown on this slide here, and not surprisingly perhaps, but it is something to keep in mind, that the lack of skilled people, resourcing, having the right skill sets is one of the biggest challenges, even so today. And then secondly, as Pieter just went through, pretty close right behind there is the lack of data or the quality of that data. So this is definitely affirming everything we just heard about the importance of having good quality data and moving to that data-centric approach. Any other thoughts on this, Pieter, before the transition to the next step?
No, this is insightful, and I think that sequence between the lack of skilled people at 19% and the lack of data and data quality at 18%, what we're seeing with this shift to data-centric machine learning, and the fact that so many of the models are getting commoditized, it would imply that lack of skilled people, in my view, may become less of a problem over time, because this becomes a commodity. You do not need a group of 20 PhDs, all with computer science degrees from Stanford or MIT, to build your models. You just need an elegant strategy and an energetic group of people that can actually make sure that your data quality is good, because the models you get off the shelf, and as long as you train it with good data, you are going to be able to make use and gain benefit from machine learning without having to struggle finding extremely skilled people. So with that said, Errol, I think I'm going to go and just give folks some examples of use cases that we have here at Cloud Factory. So the first one is a client that I think many of us would be familiar with, actually, because we all file expenses every couple of days for taking clients out or travel and so forth, and many of us use Expensify for that. So what I just described earlier about scanning and dealing with receipts that was taken through mobile phone photos, this is the Expensify use case, and they experienced like very exceptional double-digit growth, and they needed a reliable partner to just process and deal with the exceptions that are so often present in receipt processing. And there's some quite complex business rules, and we showed you a little bit earlier, like where you have the receipt and then there's a human oversight in dealing with some of the entries there, and this is what we do. So what it allowed us to do for apologies for Expensify is, 80% improvement in their turnaround time and processing up to 3 million receipts monthly. So that is quite impactful, and is not, very, very proud to have them as a client. And I think the partnership makes for a great product. And you can see here Matt talking about how Cloud Factory helped them scale and deal with accuracy and speed during that really dramatic growth that they've had. So the next one is a client called Ibotta, and they have a cashback rewards app in the market that again deals with receipts. So a large amount of receipt volume, especially during holidays. So this is another one that's fairly tricky. It's somewhat similar use case. The OCR isn't enough. You need human oversight, but the dynamic nature of their business is a further challenge in that you have to scale up and scale down, and like I said, especially during holidays. And it's kind of tough to do if you are having to do it with your own human in the loop, like your own workforce. So again, Cloud Factory provides that service. We're very proud to have Ibotta as a client, and we help them deal with these market fluctuations because we have a highly trained and scalable workforce all over the world that can support our clients, and we manage the supply and demand of those skills. So again, 50% decrease in their processing time, 50% increase in their accuracy rate, and 12,000 hours of work delivered to them every month. So that's Ibotta. The next one that is interesting is Carpe Data. So again, I actually spoke a little bit earlier about AI risk assessment. So, these guys help the insurance carriers to gain greater insight into the data, but again, predictive and actionable insights. But they still need data analysts to help validate the business data that is used to train the client's AI platform. So this is where we come in. And again, our human workforce allowed them to be effective in this space, validating data and make sure that it's not a garbage in, garbage out situation. And the results, again, speak for itself, like 97% accuracy, which way exceeds their target, and 40,000 tasks completed in a very productive and 2-year partnership that we've had with Carpe Data. And again, very proud to partner with them. And we'll have one more example, and this one is nameless at this point. But this is the example I also referred to previously, that this company uses and processes insurance claims using computer vision data, and again, with us helping to label data and intervening and giving them a workforce and tooling solution, it greatly increased the accuracy of these models, and because we have annotated the images, and we have a trained workforce that can label and model these images classifications and provide a human input onto the levels of severity, which then is used to train the models with. So results, again, in 90% accuracy, 90% plus accuracy, again, exceeded their target. We managed their QA process, and again, a very productive 2-year partnership with us and this client. So that's just to give you some real examples of applications that I spoke about more in theory previously, but these are real clients of ours, and it shows you how our human in the loop AI capabilities are empowering our clients to be effective with their solutions in the market. So to end off with some key takeaways. And the first one is, you've got to start. If you haven't started, you are going to be left behind. And we've seen just in the last couple of weeks again the tremendous sudden advances that is happening with things like Chat GPT, and everyone's saying, oh, it's, even kids are doing their homework with Chat GPT now. The point is that this frontier takes a step change leap every couple of years. When we just had one again, and what it means is that if you don't start using even what is now kind of the common stuff like computer vision and document processing, you run a high risk of being left behind and becoming so inefficient in your operations that you may not remain competitive. And then the second point to that is, yes, because the solutions are available now. Many of these blockers in dealing with large amounts of training data is now available through providers like ourselves that can partner with clients to make sure that your data-centric AI strategy is efficient, and we support you, and you get to deploy your models and gain the impact from them. So yeah, the last one, just leverage the experience. We are lucky in that suppliers like ourselves get to see the entire spectrum of what is out there in the market. And even though, of course, we're very particular about data privacy, and each client's data remains 100% their own and secure, but we still gain a collective experience from across industry that allows us to better serve our partners and to use our own learnings and skills that we develop, and specifically with our several thousand large workforce, that then is applicable to new clients. And I encourage you to leverage that experience. That is where I'm going to end today. I hope my rapid fire was sufficient, and you had enough coffee to track along. But thank you very much for your attention, and I'm going to hand to Errol. I think you've got questions.
So, yeah, appreciate it. Thank you, Pieter, for walking us through that insightful information, as I've said. We do have a few questions that have been submitted here. So let me see what we got here. Pieter, one question here. You just made a comment, I think, on your last slide about security. So this question here is, for financial information that needs to be secure, how does a provider like Cloud Factory ensure meeting compliance and security?
Oh yeah, a critical factor, and of course, you can't be in business if you don't have a solution for that. So of course, Cloud Factory is both ISO 27001 and SOC 2 Type 2 certified, which gives you the indication that we're pretty serious about security and data privacy. We're GDPR compliant, all those tick boxes that you would expect to see, we have. We have various levels of security that we offer as part of our packaging, just because in the financial services industry, you need the very highest level because of just the privacy aspects of dealing with folks' financial information. But there are other applications and clients that we deal with that may need less of it. So if you're just dealing with random computer vision application, maybe a robotics application, then if your photos are all of just a factory, then that may require less security. So we also allow that flexibility, and that has an impact on pricing. But to go back to the original question, for financial services, we have all the certifications, we have a security team, and we are very serious about maintaining privacy and security around client data.
That's excellent. Another question we have here for you, Pieter, and this goes back to when you're describing the approaches, it looks like. So someone here is saying, I'm currently using the model-centric approach. How challenging would it be to transition to data-centric? So I know you say that shift is happening. So any thoughts, guidance there?
Yeah, I would actually say it's really easy. if you follow a model-centric approach, it means mostly that you kind of have to have those metaphorical 20 Stanford PhDs around. And given that so much of these models are now commoditized, and that you won't really get too much return on investment from trying to optimize the model itself compared to the large increase in accuracy and time to market that you'll get if you focus on the data side. And the data side, there are partners like us that makes that really easy for you. But even if you do it in-house, if you have the people available, it's a less technically demanding thing to do, I would say. It's just human effort, and providers like us even take that human effort away.
It's great to hear. I think the last question I'm seeing here, does AI-assisted labeling replace the need for humans in a loop? So obviously this presentation was focused around human in a loop adoption, AI-assisted labeling being somewhat newer in the market, but as that's coming out, any thoughts you can share on that, Pieter?
Yeah, great. And just to give folks who may not be up to date with AI-assisted labeling, so of course, even in labeling large data sets, companies like ourselves are also using AI to make that easier. So you're using AI to do AI. So we now are using models to label all the easy cases and only use humans for quality control or to label images or parts of images where we're not sure what that is. So what that means is AI-assisted labeling is allowing you to kind of get to a large enough training data set much faster than in the past, just because you're being efficient. You're using automation in the process. If you're labeling animals and you already have a model that can spot a dog, then just use it to label the dogs and use the humans to label the kind of weird animals that you would see there that's not common. So that's what AI-assisted labeling is. It's using AI to generate label training data, but it doesn't obviate the use of humans in the loop, because you still need the quality control to be human. And then even once those models are deployed and you're kind of getting and gathering feedback as to how it's performing, there is still humans that has to determine, like, it's not performing great in low light, we need more low light images, or it's not spotting tigers great, we need more labeled images of tigers.
Mm-hmm. Well, appreciate that those examples to make it really clear as to the benefits for sure of keeping humans in a loop. So with that, we're actually going to wrap up our session today. Pieter, really appreciate your participating here and sharing, presenting to this audience. And to the audience, let's continue the conversation. We encourage you to follow us on LinkedIn at Cloud Factory, or possibly on Twitter at The Cloud Factory. So with that, thanks again, everyone, for participating, and have a great day.
Thank you so much.